So thank you for taking the time out this afternoon to come see my talk. Thank you to everybody who's watching online. If the tech has worked well, my wife is watching at home in the UK. So let's hope for the best. By the time this talk is finished, the internet will have emitted an estimated 140,000 tons of CO2. That is the same as almost 1 million flights one way from London to Copenhagen. 16 million trees would need to be planted to offset the pollution caused by estimated yearly Google searches. The carbon footprint of our gadgets, the internet, and the systems supporting them account for about 3.7% of global greenhouse emissions, according to some estimates, similar to the amount produced by the airline industry, and were predicted to double by 2025. Now, this isn't a number that was come up with decades ago. This was in 2020. By the year 2030, digital will be consuming up to 21% of global electricity, based on some research. The 416.2 terawatt hours of electricity the world's data centers used last year was significantly higher than the UK's entire consumption of around 300 terawatt hours. And if the internet were a country, it would be the fourth largest polluter in the world. And at this point, you might be thinking, right, that's all well and good, but how do I actually do something about it? How do I write code differently to make it more green? And that is a great question to ask. If you are already working to make your site both accessible and performant, you are probably a good chunk of the way towards writing green code, because green means better, faster, and cheaper. However, you're not always going to be able to work on these things from scratch. You're not always going to be able to work on brand new greenfield sites where you can make the decisions up front. Sometimes you need to help out those clients that you've got who are on limited budgets, or those sites you might only get a couple of hours a month to work with. So what can you do, regardless of whether you've got 30 minutes or 30K to play with? And you might also be thinking, why the heck should I listen to you? Well, teenage Rick here, he fell in love with the web. As a teenager, I was the go-to guy to update all of my friends' MySpace pages. I taught myself HTML and CSS, and obviously, I loved Firefox at the time. That picture was actually taken 17 years ago this week. But coming up to now, I am Rick Butterfield. I am currently working as a lead software engineer at Wattle, who are an agency based in the UK. I am a two-time Umbraco MVP, and I am part of the sustainability community team that formed just over a year ago. And I've been doing Umbraco professionally pretty much every single day for around 13 years now. Been properly involved in the community for about 6 or 7 years, and I've had quite the journey with sustainability over the past 18 months to 2 years. And it started here, really. This is Amy, she's in the audience, she became an MVP this week. And I was involved on a project at a previous agency where we were trying to benchmark the difference in carbon output between version 8.NET Framework Umbraco and version 9.NET Core Umbraco. And there were people who were benchmarking performance, but nobody was really looking at the carbon output of it. And this work got noticed. In the keynote last year, Philip referenced some of the work that we did at saying that modern Umbraco is at least 50% more efficient than .NET Framework Umbraco. I took a talk to Umbraco Spark last year, decarbonizing the planet one Umbraco upgrade at a time, showing off some of the numbers. And it led to some conversations happening at Spark, at some of the parties, around starting an Umbraco community team, all based around sustainability. And here we are. Here's the lovely bunch that first started up in May last year. We met for the first time on the first day of Codegarden last year. And we've been meeting every single month since, working on different initiatives to help the Umbraco community build and release sustainable websites and products. And one of the things that I'm most proud that we've managed to do is release a community package called Umbraco Community Sustainability. It's an open source package that gives you the ability to run benchmarks and run emissions tests within your own website, which I'll show you in a second. And also, I'm really proud to say that we had V14 support on day 1. But what it gives you primarily is a content app, or a workspace if you're talking in new Umbraco 14 language. And you can run reports in here. You can check the size of your page. You can get a score from A+ to F. You can understand the page size and how much CO2 is emitted per page view. You also get an overview screen as a new section that gives you your most recently run pages and your average carbon rating, average page size, CO2 per page view, and also a full list of all the pages you've tested that you can order and see the different carbon values for them. But today's agenda, what are we going to do today? How are the next 50-ish minutes going to help you when you are back at work next week with the Codegarden blues? Well, we are going to take a site, we're going to spin up just a very simple Umbraco site and take it from a carbon rating of D, and being dirtier than 59% of all web pages globally, to a carbon rating of A, hurrah, cleaner than 84% of all web pages globally. Some of the things that we're going to look at aren't necessarily going to have an impact on the scores that we are measuring, but will help to reduce the energy needed to run on devices. And I'm going to come back to what exactly we are measuring here in a second. Because we need to have a baseline. We need to have an understanding of where we're at. What were we just looking at? What exactly are we measuring? Peter Drucker says that if you can't measure it, you can't improve it. And so we need to know where we stand before we try and make a difference. Every website produces an amount of carbon, and there are ways of measuring this that are becoming standards. So, what can we measure? Well, there's 5 things that we can measure. Firstly is data transfer over the wire. When a website is loaded, the energy used is roughly proportional to the amount of data transfer. Bigger page, more energy used. And we can measure this data transferred when a page is loaded and multiply that by energy usage data that we have. And it changes slightly if you've got repeat visitors or people have things cached on their devices. The second thing is the energy intensity of web data. This is the energy that's used at the data center when things are transmitted over a network and by a user's computer or mobile device. And this varies for every website, every visitor, so we can use an average figure. The third thing is the energy source used by the data center. We assume, just when we do our calculations, that all websites use standard grid electricity for their network and the end user, because we don't always have a way to determine otherwise. For data centers, we can check the Green Web Foundation's database to see if the data center is using green energy and take that into account. We can check the carbon intensity of electricity. And the carbon intensity of grid electricity is based on the international average. We can use a lower carbon factor for renewable energy when used in the data center. And finally, website traffic. When we put all this information together, we get a pretty good idea of the emissions that are associated with an average user visiting any website. Multiply that carbon amount that we have per page view by the typical number of annual page views, and we can estimate the total number of CO2 emissions. And there are lots of tools out there that can do it for you, along with our sustainability package that we've built. You could use something like EcoGrader from ecograder.com. You put in your URL, it gives you a result back. There is digitalbeacon.co. It's great. This one is great, particularly for a breakdown per asset type, so it'll show you how much particularly images you're using or scripts. But the one we're going to be using, the one we're going to be looking at is the original website carbon calculator. Now, this was developed by Whole Grain Digital, and what we are going to do for this first bit is we're going to put the Codegarden website through it, just to see how green it actually is. And we get a score of A. Hurrah! But this gives us useful metrics to compare to. So we can see there, 0.15 gram of CO2 is produced every time someone visits the page. But what does that actually mean? What is that in real terms? Well, we can see with 10,000 monthly page views, that's the equivalent of 18 kilos of CO2, 2,500 cups of tea, 19 billion bubbles, the amount of carbon that one tree absorbs in a year. It gives us useful metrics to compare things to, and this is the one that we're going to be using for our tests. Now, next up, how do we know that we are building a green site? What is out there to help us make good decisions when we are building? The Green Software Foundation are doing amazing work to provide information on standards, tooling, and best practices in this space, and are well worth a follow across social media. And similarly, there's a wonderful group of people called the Sustainable Web Design Community Group who have been working with the W3C. The W3C are the creators of standards and guidelines for the web, and they've been working to draft standards that we can adhere to when creating digital products and services. And this first draft of the sustainability guidelines was released in September 2023 and goes into great detail about the kind of things we need to be thinking about when we are designing, building, and maintaining websites. And it's not just a technical document. There are things there around UX and around business decisions that need to be supported. And this is what's currently called a draft community group report, which means it is going to eventually be presented to the W3C for consideration to be turned into an actual standard. In the same way that we have WCAG for accessibility, this may well become a standard in the future. If you don't want to read that massive long document, there's a link on the top of it that says at a glance, and you can read a summarized version of the information. There is also, one of the things that we've done as a community team this year is to get documentation into the Umbraco docs around sustainability best practices. With so many people on the team having given talks over the past couple of years or written blog posts or gone on webinars, our conversations very quickly turn to, well, how can we get this information that we all know and we're trying to bring together out into the world? People far and wide have heard about the state of the world and want to make a difference, so what can we put out there to help them? And that's where our sustainability best practices come in. Taking all that information we know and have shared, and where the industry is at as a whole, we have come up with some best practices for writing green code when working with Umbraco. And the final thing I want to show is Organic Basics Low Impact website. Now, really sadly, this website has stopped working this week, so you can't actually go and visit it anymore. But the premise was really, really great. It would react to the carbon intensity of the grid at the moment you viewed that site. So they could tell from information from the Carbon Intensity API that if their data center was in London, how bad the grid was in London at that time. And different things would happen on that site based on what was going on. If the carbon intensity was low, you would get a fairly good experience. The higher that carbon intensity got, you would stop seeing images. You would get SVG illustrations instead. All the way up to the point where if the carbon intensity of the grid was too high, the website would shut down completely. And if you can do anything at all to impact the carbon output of your site, the things that they have come up with, the list that they have come up with is called the Low Impact Manifesto. And these are the kinds of things that we should start with. And so the Low Impact Manifesto is 10 things. Now, I think these 10 things are just ever so slightly wordy. So we're going to simplify them a little bit as we look to apply some of these principles to a site. So, let's apply these principles. What I've got here is an Umbraco 13 demo site, and we're going to run .NET Run and get it up and running. And this is the site that we're going to use to apply some of these principles. It's a very simple e-commerce site that needs a bit of attention on the sustainability front. And all the code for this, once we've made all our changes, is going to be available on GitHub at the end of this talk. But you can see, just a very simple e-commerce site. So we're going to start working our way through that list. I'm not necessarily going through them in order because I think there is a better order to think about these things. So firstly, lazy loading images. Quick show of hands, how many of you have written this HTML attribute in your sites recently? That's great. That is a very, very good amount of people to see. Browser native lazy loading of images and of iframes are supported in 95% of active browsers. The support has come since 2019, and I wish it would come to video. But this is one of the easiest and quickest things that you can do to make your site more performant and sustainable. Browser-native lazy loading has been supported in evergreen browsers for quite some time now, and is one of the best quick wins that you can do to implement for below-the-fold images and iframes. If we take a look at our demo site here, and have a look in the DevTools at the network requests for images when we refresh the page, you will see that every single image is loaded no matter how far I scroll down that page. But by adding this loading equals lazy attribute, we can make a bit of a change. And so that's exactly what we're going to do. I'm going to pick 3 of the block components that are on the page and add that loading equals lazy attribute. And once I've added it to all of them, we can refresh the page and see what difference it has actually made. So we take a look at the DevTools again, we run a new request, and we can see only about half of the images have loaded, and as I scroll the page, more and more of those images start loading. If I hadn't got to the bottom of that page, those news images wouldn't have loaded for me. And the example that I'm showing here in Safari acts slightly differently to Chromium-based browsers. Chrome and Edge and anything like that are much more eager with their lazy loading. They actually look at the first 2,500 pixels on a page. And it's different based on whether you're on a 4G or 3G connection. You'd be able to see this better with a longer page in Chrome-based browsers. That's why I've done it in Safari. So, the second thing, don't use videos. Now, a better description might be avoid videos. We can't always say no to videos completely, but we can be smart about how we use them. The web sustainability guidelines say that video and audio-heavy websites are often those that can have significant sustainability costs in terms of both storage, where the data is being stored, and of carbon intensity. And so let's do something quite drastic here. I'm going to take my video, and I'm just going to delete it. Job done. Much better. In fact, it's so much better, I didn't have to record that. That's just a screenshot. But that's not always an option. We don't always have that option. So what else can we do? Well, we could look at facades. Now, a facade is a static element which looks similar to the actual embedded third party, whether that's like a YouTube video or a Vimeo embed, but is not functional and is much less taxing on page load. Quite simply, on load, we add the facade to the page. On mouse over, it happens where it starts connecting to that third-party resource, and then on click, the facade is then replaced with the actual video map, whatever it may be. There's a great example, web component. We all love web components now, right? This is from the Lite YouTube web component that you can find on GitHub. And as you can see here, on initial load of the page, you only get 3K of JavaScript. When you hover over the element or start to click on it, you then get the YouTube API embed loaded in, which adds 540K of JavaScript, which we can stop happening for every page load, and then the video plays. You can see it a little bit in this example. I've just screen recorded here. As soon as I click it, then you start to get all of the actual CSS, JavaScript, and the actual video needed to play into the site. Thirdly, we can look at storing data locally. Now, quick show of hands, who knows what a service worker is? Okay, so a service worker is an event-driven background task that can intercept outgoing requests in your browser. It can modify navigation, and it can cache responses as well. You've probably heard about service workers in the context of PWAs, progressive web apps, because they enable some of that essential UX enhancement like client-side caching, offline first applications, and push notifications. But in effect, they allow us to intercept every fetch request from the browser for resources, JavaScript, images, fonts, media, etc., and decide what should happen with each request. And so in our demo site, we're going to add a very simple service worker. So I start by, in my www root folder, adding a sw.js file. I'm going to add a version constant. This comes in handy later when we're trying to invalidate the cache if there's a new version of the site that we want to store offline files for. And then this offline files array that I'm creating here, these are the things that are never going to change. If you're building an app, it may be your logo or a font file that you know is always going to be used. You always want that caching. Next, we are going to start looking for different events that are happening when you are running your service worker. And there's three main things that we're looking for. We're looking for an install event, an activate event, and a fetch event. And so with our install event, the install event happens when either a PWA is added to your home screen or you visit the site. If you look at my website, at rickbutterfield.dev, there is a PWA there that stores some of these local files. And what we're trying to do is just open a cache that is in browser. We've called it fundamentals because it's stuff that never changes. And then once we have opened it, we're going to add all of our offline files to that cache. And once that is done, we can just continue over it, basically. The next thing that we're going to add an event for is the activate event. Now, the activate event happens every time a new version of the service worker is run. And so what we're trying to check for here is, Does the version key that I've added at the top of the file match what version is stored in the browser? And so on activate, what I'm looking for is anything within the local storage that doesn't match my version key. And then once we've got those values, we're checking here for whether the key that is found in browser actually starts with our version identifier. And that version identifier, I find it really useful to update with some step in your CI/CD pipeline, like a PowerShell script or something you can run to take your, maybe your Git commit ID, something like that. Anything that doesn't match at that point, we're going to delete. We don't need it anymore. And then the third and final event that we're going to track is the fetch event. So for every request that comes out of the browser, we can intercept it and do something about it. But there are certain constraints we need to think about here. We don't want to intercept every request. We don't necessarily want to intercept third-party requests. We don't want to intercept post or puts or deletes because we don't want those things to be cached. So the first thing we do is check, is that method a get? Are we getting something from the server? Then the destination that we're looking at tells us a little bit about what kind of item we are getting. Is it an image? Is it a style? Is it the actual document itself? And so we're adding a few checks here to see what kind of element we are dealing with. You'll see when I add this video one, there isn't a specific destination that can be added for video. So we're checking, just in this case, is it an MP4? You could add extra checks for other video formats. But we carry on and we see we can check for script files and we can also check for styles as well. And so once we've done that, we can start to intercept these requests. Now, I'm going to paste in some regex here. All this is doing really is checking, is the request, the URL that we're going to check, coming from my local host domain. You can add an extra check in here to say, is it coming from a production domain if you only want to cache certain things. Our first line of regex, line 32, is checking for anything that's coming from our assets folder in our built files or from the media folder, and then static assets is checking just the assets folder. So we have two booleans that we want to check. Is it an allowed URL and is it a static asset? And then once we've got that, we can start to actually do something with that request. We check first, is it a GET request? Is it an allowed URL? And is it definitely not the document? In this example, we don't want to store that document. You could store offline documents if you're building a PWA so that your users have offline access, but we aren't trying to do that. What we're checking for next is it a script file, is it style, and is it an image that is a static asset? Is it something we've added to the solution? If it is, we're going to do a particular thing with it. Our second check really is to see, is it an image or a video that is not a static asset? So is it something coming from Umbraco's media library? We're going to store this slightly differently. And what we can start to do now is actually intercept that request. So when the event comes in, we can do a respond with and actually do something with it. We first need to check, does it match something that is already in the cache? Now this is checking for the exact URL, including query string. So if you're doing any sort of cache busting query strings, then you might find that you are adding lots of different bits of information. What we're going to do is run a function inside of here, basically to get the file that we're expecting. And we're going to create a cached copy of it in memory, and then set a new cache location variable. Once we've done this, we can do some other checks to see if it's an image. I want to store it in a new cache location called static assets. So the only other thing that we're doing after checking if it's an image or a script or style and we want to save it in a different location is basically to open our cache and then put that element into the cache, put that object into the cache and return the response. And then the final things that we're doing, line 61 and 62, we're checking, is a response found in the cache that we opened right at the start? If it's not found, then we will actually get it from the server and cache it. Otherwise, we want to return the response from the server. And we can do something similar for our images and videos that are coming from the media library. I'm just going to paste something in here rather than writing it all again, but effectively it's doing the same thing. We're choosing a location to store it, we're then opening the cache, putting it in, and then serving it from the cache if that version number matches. And so we can go into our layout partial, and we can actually add something that is going to register the service worker in the browser. We do a check, very basic check to see, does service worker exist in the browser? It does for all evergreen browsers now. And then when the window has loaded, we actually register that service worker file. We'll log something to say that it's registered, we throw an error if it doesn't, or we add a warning to say that it is not supported in the browser. So we go back to our browser, and we refresh, and we check in the console, and we can see that we have our service worker registered. And if we go to our network tab now, we can see all of the requests that loaded that first time before the service worker got activated. And then when we refresh the page, we can actually see that the transfers of some of those things hasn't happened. Because they've been returned from the service worker, they are returned from in the browser. No network requests have gone out to the server, and we've got those stored locally now. Chromium-based browsers have much better dev tools for showing this. If you go to your application tab, you'll be able to see the service worker. You can check whether it's registered, you can unregister it, you can clear everything, and you have this cache storage section that actually shows you what has been stored, and you can manually invalidate them if you're testing things. One of the other things you could use, and I saw a great example of this, is local storage. Now, if anybody looked at Joe Glombeck's Codegarden what to bring list, there were checkboxes on it, and if you were to tick those checkboxes, it would store the information about what you have ticked in your browser. You wouldn't be going away to a server to store that information, but if you were to view it on the same device again, you would get your list back. Fourth, we want to limit screen light emission. And of course, we're talking about dark mode. This is one of those things that isn't completely tracked by carbon calculators, but it does have a massive impact on device usage. And it has been a first-class citizen on the web since 2018. It's supported by all evergreen browsers, and I don't think we do enough to take advantage of it. Here's my website, rickbutterfield.dev, and here it is in dark mode. This is a blog post I wrote in October 2018, when some of the first browsers started to support it. And I think a lot of people think that adding dark mode support is going to be a big piece of work, but why not add it progressively? Component by component, testing as you go until you get something that you are happy with. You can start by creating a basic color palette, dark color palette that matches your brand colors, and iterate from there. Start with global components like headers and footers. Add more and more as you test and release. My demo site that I've set up for this is actually using Tailwind, and Tailwind has dark classes baked in. If you start anything with a dark : modifier, you can dictate what that element will look like and how it will respond based on dark mode being turned on. So what I'm saying here is I want to change a few of these elements to use a different color when they're in dark mode. I'm changing some background colors here. I'm changing some text and hover colors. You can see here, so I want the text to be white when it's in dark mode. When you hover it, I want it to be a much paler green color. And the difference this actually makes when you go in the browser, you can toggle whether you want to display your site in light mode or dark mode within your dev tools. And if I force dark mode, I can see that my navigation there has actually changed color. Now, if you're not using something like Tailwind or any sort of CSS framework that has dark mode built in, you can still write all this yourself. You can add to your root element, you can add some CSS custom properties. I'm adding here, I've got a background color, and I've got a background color that I want the site to be in. When it's dark, these are only example colors. This is not great for color contrast. But on my HTML and my body elements here, I'm going to set the background color to one of those variables, the lime green. You can use the var notation to pick one of those variables. And then I'm going to add a media query that checks whether your user's device is set to light mode or dark mode. So I'm saying here, if the user has chosen dark mode, that prefers color scheme dark, then set the background color to something different. Now, this is the traditional way of doing it. This is how we've been doing it since 2018. But there is actually a slightly different, newer way that has just been released that you can do this. By going back to your root and adding the color scheme property, setting it to light dark, what you can then take advantage of is a light dark function that is built into CSS. This is my light dark function, and so I pass my first parameter is the light mode color, and the second parameter is the dark mode color. Now this is very new, so it's not amazing support yet. What does it say here? 69.31%, but it is coming, and it's something that we can think about taking advantage of. The fifth thing is to load essential scripts only. And I'm going to ask a very important question here. Do you really need another analytics script? Check your scripts, especially third-party ones. Can you load anything async? Can you load anything deferred? Here's another question, and something I check for on lots of websites. Why is Google Maps loaded on every page when you've only got a map on your contact page? Can you choose to conditionally load certain scripts based on what blocks, what elements you are adding to your site? Sixth is that we can optimize and limit fonts. Users might not care that you are using a brand font. Brands love custom fonts. Your clients probably love custom fonts, and that is fine. But if you're building an app-like system or a portal, have you considered using a system font stack? If you go to GitHub's website and inspect the site in your DevTools, you will see that nearly everywhere you look, it is using a font stack that looks a bit like this. Apple System, Blink Mac System Font, Sego UI, Notisands. These are all system fonts that are built in across different browsers that can be used without having to download a third-party font. And there are some great examples of font stacks you can use at systemfontstack.com. You could also think about subsetting your fonts. Maybe there's only a certain set of characters that you need to use. You can then provide a slimmed-down version of that font if you're only using it in a particular way. Can you remove some excess weights? Are you only using a 400 and a 700 weight? Or is it going to be better to load a variable font and then cache it in the browser? This is an example of how variable fonts work. There are different axes that you can edit, whether that be the weight or the width or optical sizing or slant to make it italic. But by downloading one of these fonts and caching it, you can actually save some of those round trips to the server. Seventh is to compress data. And now there's lots of different ways that we can start to think about how we can compress data. It might not necessarily be your decision or something that you can do, but can you push your site to the edge? Can you use a CDN? Can you enable gzip or Brotli? Can you use Cloudflare? Push that data to the edge onto a CDN and closer to your users. Services like Cloudflare have made the idea of using a CDN, moving your cached content closer to where users are consuming it so much easier. Their free plan comes with so many different things like DNS resolution, CDN, free SSL, and DDoS protection right out of the box. Have you thought about statically generating your site? Adam Prendergast did a great talk yesterday about Bake Don't Fry, about Astro, which you'll be able to catch afterwards. I've seen that talk at a meetup in Manchester, and it's a great. My website runs on Astro and uses Umbraco headlessly so that when I publish content, that site is regenerated rather than always making those round trips to the server. Do that heavy lifting on the server and push as much HTML to your users as you possibly can. Can you check any long-running scripts on your site? Is there any JavaScript that isn't in use? Are you still using jQuery when you don't need it? All good things to check. One of the things I love about Umbraco is if you go to any page when you're locally debugging and add $UMB debug equals true, you get the MiniProfiler. Now, on a bigger site than this, the MiniProfiler would look slightly different. And what it's doing is it's actually showing you the time taken to render everything that you see on the page. And so if there's a partial in there, if there's a block item in there that is actually doing something that's a bit heavy, you would be able to see it here. One of the best examples of this I actually saw, which I never took a screenshot of, was there was a news section at the bottom of the site and you could see 2 of the latest news articles. But what it was doing is going away to the server, getting all of those articles, loading them into memory, and then doing a take 2 on the very last step to actually only return 2. So it's overkill for what it actually needed to be. We can think about correctly sizing images as well. How many of us are guilty of just linking straight to massiveimage.jpg without adding a width or a height parameter so that it gets processed by ImageSharp? Even better, doing it in Umbraco makes it even easier for us to do it. If we're looking for a property called image on our model and we do URL, well, why don't we just change that to get crop URL and load a smaller version of that image? Even better, add this little bit on the end and make it a WebP image, which are shown to be generally smaller than equivalent JPEGs. Keep your version of Umbraco up to date as much as you can. Like I said earlier, we had a mention in the keynote last year around the fact that the work we did said that modern Umbraco is at least 50% more efficient. With every new version of .NET, we should be able to see the underlying performance improvements then reflected in Umbraco. If you've never checked out these blog posts when new versions of .NET are out, they are incredibly long and long reads and very, very heavily technical. Lots of it goes over my head, but there is some great stuff in there that every new version of .NET that we get, there are always performance improvements. And naturally, because we're just using Microsoft technology, those performance improvements come to Umbraco. The 8th thing that we can look to do is to adapt to available energy. And one of the best ways that I've found slightly UK-centric is the carbon intensity API. Now, if you haven't heard of what the carbon intensity API is, it is a free, open API that is provided by the UK's national grid that allows you to see the current grid usage of the current carbon intensity of the grid where you are, based on your region or even based on postcode. And it is just a brilliant open JavaScript, JSON-based API that gives you some really, really useful information. So you can see the tests that I did here. Well, it's showing in 2018. Yeah, but you can see some of the intensity. You also get a future forecast as well based on previous numbers. And even better for us .NET developers, there's a NuGet package that wraps it as well. So one of the things I wanted to try with this site is actually change some of what is going on the site based on the live carbon intensity. And so I've installed this carbon intensity package. It's open source, and I'm going to actually suggest some changes to them because I think it should be a service that is injected rather than using controllers. But what we're going to do here is, assuming that the data that we're getting is from the Azure region in London, for example, we're going to check the regional intensity of London at the time that the page loads. And the data that is coming back from it, we're going to then do something about it. And so we can see we're checking the intensity index here. Now, the intensity index really should be an enum, but at the moment it comes back as a string and tells us whether it is low, moderate, high, or very high. And so we're going to check if the grid intensity at that moment the page is loaded is either high or very high. We can do something different on our page with that information. And so here's the check. We're checking to see if it's high or very high. And once it is, we set our high intensity Boolean to true. Once we've got that value, we can then do something different. Now, what I'm going to do here is effectively load a blurred, scaled up version of my hero banner, just so that we're not requesting a massive 1000 by 800 image from the server. So instead, what we're going to do is request a 10 by 8 image from the server. Again, we could potentially cache this in our service worker. We're just copying over the same attributes that we have for our other one, so empty alt text there, which should be alt text in, but then our classes as well to make sure it's displayed exactly the same. Some people have started to call these blur hashes as well. I don't know if anybody's heard that term. I hadn't until I was starting to research it a little bit more here. But this is what's called a blur hash because it's showing you a representation of the image. What we're also going to add is just a little label so it's immediately obvious to us what the grid intensity is at that moment that the page is requested. And so we're going to add a little red label with a bit of padding and some text in it to say what the current grid intensity is. We can skip over this because it's just going to load the variable. And you can see here that the image, the background image loaded as a very blurred, low resolution image before the video loaded. And then we are seeing that the grid intensity at the moment I requested that page was high. Now, one of the other things I thought I could try and do is to get rid of the video if the grid intensity is high. I don't want to do another request to the server that could potentially be streaming a 10, 20, 30 meg MP4 in. And so what I'm doing is if the grid intensity is high at that moment, I'm just not rendering that image at all. It won't be sent in the HTML, which means that the request will never go out to get that image. And we can see how much better that's made it. So much better that this is a screenshot as well. I don't have to record a video to show you what that is actually like. You could potentially wrap this up in a tag helper. You could wrap this up in some way to make it easier so that you don't have to write your code to check that grid intensity every time. The ninth thing that we can do is to inform users of their impact. Let your users make a choice about how they want to access your site. Do they want to access it in a more sustainable way? If you saw the winner of the Green Award from Codegarden last year, the Herning.dk site has an option for you to reduce the site's climate footprint. You are given the option to click a button and you get this great version of the site with no images, and it's grayscale, and as you can see from the text, you reduce the footprint on average by 30% for each page and up to 70% on pages that originally had many images. And there are lots more sites starting to do this. I know Boohoo did it for a little while. I think they've got rid of it now, where you could add like a toggle to make the screen darker, make it dimmer. And then finally, minimize the power usage on the device. I think this one should be number one, because by doing all of the things that I've talked about, you are actually minimizing the consumption. Long-running scripts, large video or images, lots of requests going out to the server, all take power. Think about statically generating your site. Think about heavily caching those resources to give a better green experience to your clients. And one thing you might be thinking is, how do I convince my boss to give me the time to do this? Well, we've managed to get through 10 examples here in half an hour. Half an hour may be all you need to start making some of those changes. But I think the main thing is that these three things overlap: accessibility, sustainability, and performance. A site which is quick to load will be more sustainable by definition because minimal assets get transferred. But a site that also has minimal data transfer can use system fonts, and system fonts are great for accessibility. And so when you're taking into consideration the whole picture of sustainability, accessibility, and performance, all three of these things can have an impact on each other. So what can we, as technologists, do to have an impact with the code we write every single day? My biggest encouragement is just to do something. Don't let this just be information. We have the power at our fingertips to create a better world for future generations, so let's use that power for good. I'm Rick Butterfield. This has been Green Code, a blueprint for eco-friendly websites. Thank you very much.